Good morning, everybody. Welcome to another wonderful Monday morning of Chem 1211 with your host, me, Dr. White. As you know, Saturday I picked up, well, you don't know, but I'll tell you now, I picked up test number 1, and by Sunday morning, I had graded it, posted your grades in Blackboard, and also to each of you sent out an individual email with the points you got for each answer. Also yesterday, I sent out, since I'm not going to be able to hand it back to here. By the way, there's your test number 1 file. But anyways, I won't be able to hand it back because I tried to get the division to allow me to put it at the main entrance receptionist at HSC. And they said, no, we're not going to do that. Well, since you're not and I'm not at COD, we were face to face, I'd be handing it back. But what I did do is I sent you a copy, blank copy of test number 1, so you can see, go back and look at your answers or the problems, and you can see which ones you got wrong, and you can figure out how to do them correctly. And 2, blueberry tea, good stuff. You'll be able to use test number 1 as practice problems for test number 2, my final. But anyways, what I'd like to do today is I'll be going through test number 1 answers. Now, before I do that, a lot of you did not do good on test number 1, and that's happened in the past. Luckily, because of the way I'm grading, and look at my syllabus, you'll see, and I'll go over it again after we go through test number 1. You have 6 quizzes and 1 test, test number 1, and you can drop any 2 quizzes or test number 1 and keep the 6 quizzes. So no matter how you did on test number 1, all of you still have a good chance of getting a very good grade in my class, but you have to do something different. Now, one of the main problems I saw on test number 1 with many of you is you really didn't understand the concept of unit analysis. Tomorrow, after the lab, I will go through unit analysis again with a couple important problems. If you can't make it, it will still be in the video. Now, today, I'm going to cut out test number 1 answers. For those of you who are not here, I will be able to show you the answers or go through any problem in my office hours. Now, I know some of you are working or whatever during my office hours. If you need to see the answers for test number 1, email me and we'll set up a special Zoom meeting between me and you so you can see your answers. Because honestly, I want everybody to do well in class. But from what I saw in test number 1, guess what? You need some help, and I'm here to help. Now, before we go through test number 1, there's something I do want to talk about that I also sent out. And bear with me while I log into Blackboard. All right, thumbs up, people. Do you see Chem 1211 quiz dates on your screen? Thank you, thumbs up, people. All right, I sent this out yesterday evening, and I finally figured out here are the tentative dates for quiz 3, 4, 5, and 6, the remaining quizzes. Now, I haven't put on, but quiz 3, which is a week from this Wednesday, will cover the gases chapter, or what is that, 11 or whatever chapter. on gases. And I'll post later this week more information about quiz 3. Now, please note all quizzes will be on Wednesday. You'll have until Thursday morning, 11 or 1, 12 p.m. 12 p.m. Yeah, 12 p.m. to hand it in. They'll all be online. Only test 1, test 2, and the final exam will you have to take at the COD testing center. And again, these dates, here they are. You should have been sent an email for this. Also, I have set this so it will stay up for the rest of the semester, this announcement. Other announcements, as you know, after a certain time, I have them taken off Blackboard. This one will remain. So here are the test dates, and I'll talk more about it later in the week about quiz 3. First of all, I got to write it, but it will be on gases this Wednesday. Tomorrow. Tomorrow, I'll go through the gases problem set before our lab. It's going to be a good lab this week. And please show up or watch the video. All right, what I'd like to do now is go through. All right, I will be cutting this out of the video. However, if you are not here today, come to my office hours. If you can't make it to my office hours, guess what? Email me and I'll set up a special when we're both available on Zoom, a meeting so I can help you out. I want all students to do well. Now, if you've been handing in all your labs, which most of you have, by the way, I'm caught up to labs. Look at Blackboard. There are a couple of you whose labs I couldn't open up, and today or tomorrow I'll have to email you to tell you to email me those labs. Now, an important question you should have, what grade am I getting right now in your class? Now, I should point out, there's still a lot of points to be earned, so this is just an indication. It's not a final determination. All right, there are 2 ways. Everybody see method A on your screen. Thank you, Gianna. All right. If you get a number X, which is the sum of your 2 quizzes plus test 1, divide that by, made a mistake. You divide that by, did it again, by 200, you'll get a number. If that number is 90 and above, you're getting an A. If it's 80 to 89, B, 70 to 79, C, 60 to 69, D, below 60, F. That's in my syllabus, that breakdown. Now, there's also a method. B. And that's a percent. I think I have to multiply times 100. Let's see. Yeah, both of these would be times 100. This would be times 100. This would be times 100. Sorry about that. Now, in method B, you either take this calculation or this calculation to get Y. And that's because you can drop test number 1 or 2 quizzes. And whichever of those is the higher number, Y, if it's 90 to 100, you're getting an A, 80 to 89, B, and 70, 79, C, 60, 69, D, and less than 60, F. And that's how you get your current grade. That's assuming you've been handing in all your labs. If you look at the lab, excuse me, you look at the lab scores, you do your labs, most of you have been doing them good, and I give you a good grade. I'm not a nitpicker. Oh, let me take off points here. No, yeah, that looks good. I'll give you the points. So that's how you do it. By look, it's time for a break. We went a little into it. Come back in 5 minutes, and I'll tell you a little more about where we're going. And I'll see you in 5 minutes at 9:57 approximately. And I'm going to go get up and stretch. See you. I'm back. All right. Again, test number 1 answers that I just went through, I'll be cutting out of the video, but if you missed it, come to my office hour or email me and I'll set up a special Zoom meeting with you so you can see whatever answers. Hold on. Get settled in my chair, my comfy chair here. But anyways, I will set up a special meeting. Now, one of the things I did in the past, and it works, if you get nervous while you take a test, it's called test anxiety. And that is a problem a lot of students lately I've seen have. I went through a method how to do that. If you missed that, or if you're not sure you're doing it right, come to my office hour or email me and I'll set up a Zoom meeting. It works. At the other school, I'm teaching Elgin Community College. This semester, I'm teaching organic chemistry, which I also teach sometimes at COD, which many students think is a much harder course than this. I don't know why it's organic chemistry, but I'm an organic chemist, so I'm biased. But they do have trouble. The student learned the method, had a little difficulty at first. First test, she barely, and you don't know who I'm talking about, and most of the class over there are women. So when I say she, I'm not identifying a student. She barely got a B on the first test, learned the method properly. The second test, she got one of the highest A's in the class. And the second test was much harder than the first test. All right, once again, you all have a good chance of getting a very good high grade in my class. But whatever you did on test number 1, if you didn't get a good score, you've got to do something different. I can help. Come and see me. Now, I forgot to mention, this I don't like to say, but the average on the test was 67, which I expect my test students should be able to get in the 80s for my average, like 85, 90. Now, I can say that 6 students got 95 or higher. There were 5 bonus points, and 1 student got 101. What that tells me is I didn't write an impossible test, because if I did, nobody would get above 60. I don't do that. So study. Just watching these videos won't help you. You have to do the practice problems. Before I continue, any questions on anything at this point? All right, let me open up. All right, everybody see solutions, chapter 12 and 13 on your screen. Remember, tomorrow I'll go through chapter, thank you, all my thumbs up people. And we talked about, started last week, a solution is a homogeneous combination of 2 or more substances that retains its own chemical identity. And example, my T is a solution. You buy gasoline, that's a very complex solution. Or if you don't buy it, if you go by a gas station, the gasoline they're selling is a complex solution, a lot of components. The air you're breathing right now is a solution. Remember, in a solution, the solvent is the component that's present in the greatest amount, and all other components are called solute. And I talked about the different types of solutions. I also talked about solubility. And there's a saturated solution, which has the max amount of solute present. Dilute, very small amount. Remember, bartenders don't like saying, did you dilute this drink? They don't like that, even when it's true. Concentrated, there's a large amount of solute present. Remember, I talked about concentrated orange juice or orange juice concentrate. And the most important, aqueous solution, which is a solution in which water is the solvent. Now, non-aqueous, where there's no water present in that solution, water is not the solvent. Actually, I should change this definition. Non-aqueous means there's no water present. And I talk about solute formation with the switch click for this off. All right. Does everybody see like dissolves like on your screen? Thank you, Brianna. All right. This is probably one of the most useful things I'll teach you this semester. Click, switches on. If this were a dial, I could turn only 1 to 10. I've just turned that dial to 20, even though it only goes to 10. I stole that from the movie This is Spinal Tap, which is an interesting cult movie you should see. All right, what is like dissolve like? It's a rule of thumb. How do you like that? Thumb. It could be this thumb too. And a rule of thumb means most of the time, like 95% of the time, it's true. It's not 100% true, because then we'd call it a law. But most of the time, 95, 98%, this is true. And what is like dissolve like? Substances of like polarity tend to be more soluble in other substances than substances that are different. Another way of saying that is things that are polar are soluble in polar things. Things that are nonpolar are soluble in nonpolar things. This is a generalization, and it's not true for inorganic ionic compounds always, but for organic and many of the molecules you use in your life is true. All right, this is something you should know. Everybody see like dissolves like on your screen right now from my whiteboard? Thank you, Brianna and Rochelle. I hope I'm pronouncing her name correctly. All right, what are polar substances? The most polar is water. All salts are polar. And all, if you were taking my organic chemistry, alcohols are polar. Now, what are nonpolar? An example of that would be gasoline, vegetable oil, baby oil, Vaseline, which is also known as petroleum jelly. I'm using a trade name there. Now, there are other nonpolar substances. Now, what that means is if you put water and vegetable oil together, one is polar, one is nonpolar. They won't mix because like dissolves like. And how many of you have ever seen oil vinaigrette dressing? My mother's favorite was wishbone. Once you learn how to make your own, it's much better than wishbone, and it's wishbone dressing. She loved the Italian wishbone. We always had that on our dinner table for when we had salads. If you take a bottle of Wishbone, hold on one second. All right, everybody see the bottle of Wishbone Italian dressing? That was my mother's favorite on the screen. Thank you, Gianna. Notice how there are two layers in there, a lighter top layer and a lower, darker bottom layer. That's because one layer, the vinaigrette, vinegar is essentially water and a chemical called acetic acid. And the oil is vegetable oil. There's some seasonings in there. And notice the French and Russian are not homogeneous because it's not an oil water mixture like that. There are other things which I don't teach in this class that make them homogeneous. But because like dissolves like, water polar, vegetable oil non-polar, that's why it doesn't mix. Now, years ago, I had a very smart Chem 1, 1211 student. And after I taught that, if I go back and I'll show you the screen, the student asked, does that mean if I take vegetable oil and Vaseline, it will mix together because the like dissolves like? I said, no, I've never done it. Next time we go into lab, if you don't mind, this was in a classroom when I said this, I'll get you some Vaseline and baby vegetable oil. Do you mind mixing it together and see what happens? He said, no, I'll do it. And guess what? Like dissolve like held up. Now, what this also means is if you look at, if you ever go to a gasoline station after a rainstorm, and if you see puddles by the gas pump where you drive your car on the asphalt, you'll see when the sun comes out, have you ever seen it looks like a rainbow on top? Have you ever seen that? Anybody? Nobody. Oh, that's sad. Oh, I see one person. All right. What you're seeing is the rainbow is because the light comes down from the sun now. And when people pump gas, I don't, but I've seen enough people, they'll spill some on the ground. And the water and gas form gasoline form two layers, and the gasoline is on top, and the light comes in. When it hits those two separate layers, it refracts like a prism and gives the colors of the rainbow. But you didn't know that. All right, let's look at a problem with like dissolves like. Hang in there while I write this or print it. If I had been writing it, I would have been done already. All right, everybody see 5 points on your screen? Thank you. Thumbs up, people. All right, let's go through this. Compound Z is soluble in vegetable oil, but not in water. And on a test, I'd print out the whole vegetable oil name. Compound Y is soluble in water, but not in vegetable oil. What are the polarities of compound X and Y, and how do you know this? Well, what are we trying to find? Now, we're given compound Z is soluble in vegetable oil. And if we go back up here, vegetable oil is nonpolar. And because like dissolves like, things that are nonpolar are soluble in nonpolar things. Things that are polar are soluble in polar things. When you mix two together, they're not soluble. And therefore, since compound Z is soluble in vegetable oil, but not water, and vegetable oil is nonpolar, therefore, oh, I had X, I was going to use, hold on 1 second. I should. Therefore, 3 dots means in math, therefore, and Z is nonpolar. Now, we're also trying to find Y. Y is soluble in water, but not vegetable oil. And this is something you got to memorize. I'm talking about now for quiz 4. I'm not going to give this to you. Water is polar and vegetable oil is still nonpolar. And like dissolved like tells you things that are polar are soluble, except for some inorganic, for the most of the part, even our salts, in water. And therefore, since Y is soluble in water, but not vegetable oil, Y is polar. And how do we know this? Because like dissolves like. So remember, you should know this. Like dissolves like, things that are polar are soluble in polar things. Things that are nonpolar are soluble in nonpolar things. One other thing, which I won't put on a test, but if you take my organic chemistry, what else is nonpolar? Dirt, yes, dirt, and also grease, which is why water alone doesn't get dirt out of your clothes. If you take my Chem 1212 here, or Chem 170 at Elgin Community College, you'll learn soap helps because of like dissolves like, helps water get dirt off your clothes. All right. Again, this is probably one of the most important things. Medicine is usually polar. If you look, and I teach this in organic chemistry, the actual structures, but if you look at a lot of the medicine, both over the counter and the key ingredients in medicine you are given by a doctor, you'll see they're polar. Why? Because if you take it by a pill or a liquid, it looks like I'm having a shot, like cough medicine, it goes in your stomach. And what's in your stomach? Water. What's in your blood? Water. And because like dissolves like, having medicine ionic helps your body transport it. Now I'm way beyond my knowledge of biology. Last time I took biology was freshman year of high school. Wow, that was decades and decades ago. I don't want to remember. No. But anyways, a long time ago. But that's why medicine is polar, because like dissolves like. Isn't it scary? Chemistry is everywhere. All right, let's continue. Oh, by the way, switches off here. Chemicals that have both polarities, the same molecule, polar, nonpolar, are called surfactants. And this is an area I'm a world authority in. I have a number of patents in surfactant chemistry. And your soap, hand soap, and if you liquid or solid, your laundry detergent, those are all surfactants. Now, what if we were together face to face and we're in a lab now? And I talked to one of the students, I say, can you go and make me a solution of salt and water or sugar and water? And then while you're doing that, I turn to another student and say, can you make me a solution of salt and water or sugar and water? And what you're going to do, the student's going to put some salt and water, mix it up, and here's a solution. Like if I put salt in here and mixed it up and dissolved it, or if I put sugar in here and I mixed it up with the water, and I have either salt and sugar solution. Now, if I ask two different students to do this, I like special effects. Anybody getting dizzy? Hope not. But anyways, you get two different students, you guess what? If they both mix, say, like water and sugar together, will it taste the same? Maybe not. Why? Because they mix different amounts of water and sugar together. And what we call that is concentration. And the concept of concentration of a solution allows people, chemists, to make solutions, like when you buy pop or other things, that is always the same. So let's look at concentrations. Now, concentration, and I'll never ask on a test, so click, the switch is off. That's the amount of solute present in a specific amount of solution. And this is called concentration. And if you buy anything that's a solution, concentration plays an important role. If you go and buy some medicine that's like cough medicine, the concentration of the key ingredient in that medicine is important. And if you buy, how about summer's over, bug spray, and I'll talk about this later on, like Off or other brands, the concentration of the key ingredient that keeps mosquitoes and other insects away from you is always the same. So what you bought yesterday will be the same as what you bought today, and will be the same as what you buy a month from now. Now, there are different types of concentration. The first one is percent concentration by mass. And this, by the way, switches off for this right now. Percent concentration of mass is the mass of the solute divided by the mass of the solution times 100. Again, percent mass, and this won't be on a test, but you still should be familiar with it, is the percent mass of solution of solute divided by mass of the solution times 100. And the mass of the solution is mass of solute plus mass of solvent. So the higher the percent mass of a solute, the more there is present in a solution. The higher the percent mass of a solute, the higher there is in a solution. Now, click. I will not ask you to do the problem with this on a test, but this is an important concept in your daily life. How so? Well, many years ago when I bought this house I'm living in right now, which I like, I've been here a long time. It's a nice house. I have very nice neighbors too. I'm very lucky that way. But anyways, I just bought the house and it's time to mow the lawn. I have my brand new lawnmower because I had lived in an apartment building before, so I didn't have to mow the lawn. When I was younger, I lived with my parents. That was my job. But anyways, I go out, it's about 8 in the morning on a Saturday to mow my lawn. And I go out, start my lawnmower, start walking around, mowing the lawn. All of a sudden, I'm getting attacked by all these mosquitoes. And I shut off my lawnmower, put it away, and said, I need a repellent. So I go over, and I don't go over there often. All right, everybody see off on your screen from Walmart? All right, thank you, Brianna. And I see, go to Walmart, and they have an area where they have different products. The name brand is off, and Repel is the Walmart. Now, I know that the active ingredient, this because I'm an organic chemist, in any mosquito spray is DEET, and that's an acronym for diethyl ethyl-toluamide. And if you look on the back of, well, it's on the front, you can barely see it, but everybody see at the bottom, now it's clear, 40% DEET. And that's by mass percent concentration. The higher that number, the more the active ingredient, the thing that keeps mosquitoes away. Now, if you look at, which I did, off deep wood, and you don't have the label here, but if you're in the store, oh, here it is, that has 25% DEET. Now, being a chemist, organic chemist, the price of the Repel, which has also more chemical, here they have 2 bottles for $6.94. Here they have 1 bottle of the off, which has almost half the active ingredient at double the price. Which one did I buy? Well, Dr. White knows percent mass concentration. The higher that number, the more that active chemical. And it has more active chemical, more product at a lower price. Guess what I bought? The Repel. And good news, the mosquitoes and other insects left me alone. Now, that's true for many things. A number of years ago, my sump pump died and I had a minor flood in my basement and I got it all cleaned up. Oh, what a mess that was. But anyways, I still smelled some mold. And again, I went over to Walmart and they have different sprays to get rid of mold. And you have a name brand, Clorox, and the Walmart brand. And the active ingredient, called a quaternary ammonium salt, which I am a world expert in. I have a number of patents in what's called quaternary ammonium salts for various uses like fabric softener and antimicrobial, anti-mold. And I picked up the 2 cans, and there again, percent mass, how much in a solution, in this case, it's a gas and aerosol. The Walmart had doubled the active ingredient, the quaternary ammonium salt, than the name brand. Had a little much lower price. Guess which one I bought? The Walmart. Now, that's true a lot of things at Walmart. Walmart products, I have to admit, are very good quality, even though I stay out of Walmart whenever I only go there a couple times a year. It's a dangerous place for Dr. White to walk through. I spend a lot of money, but so is Costco. I guess so is Jewel. All right, that's percent concentration. Now, there's another way for measuring concentration. Remember, concentration is how much of a solute is present in a solution. And the other way is by percent volume. And click switches off. And percent volume is volume of the solute, how much by volume, for the total volume of the solution times 100. That's percent volume. And the higher the number, the more solute that's present in that solution. Now, the only place I really see percent volume is on wine bottles telling you how much alcohol is present. Hang in there 1 second. All right, everybody see the Pierce Porter, Golden Trachen, Riesling, Spätlese? All right, now, having worked for a Dutch company, 2 of them actually, that both had major research and production facilities, plants in Germany, they got 219 out already. I was in Germany a lot. And an inexpensive, outstanding wine is the Pierce Porter Golden Trachen wine. It's a white wine, and I like it much better than any French wine. That's my, let's see if I can find some more. And they do. They're out of stock here. But anyways, in German wines, and any wine, if you notice here where it says proof, and also a lot of times say percent volume, that's where you find concentration. Now, time to give you a education in German wines. The area I like, there are other German wines, but the Pierce Porter, Peace Porter, Golden Trachen wines, Rieslings are my favorite. It's a white wine. There's a Cabernet, Spätlese, which this is, and Auslese. And what that means is when they pick the grapes, what's the sugar content? The longer they leave the grapes on into when there's a frost, the sweeter they are. Cabernet is the least sweet. Spätlese is in the middle, and Auslese, very late out a long time, is the sweetest. And Dr. White really likes his Auslese as opposed to the Spätlese, which I also like. And now you have an education in German white wines. I don't like French white wines, German white wines. But then again, I can close my eyes. I remember in one town, I was in Elton, and also there's a small village nearby, Hochelton, that I remember we were in an outdoor cafe and we were having some of the Peace Porter. I always say Piers, it's Peace Porter, Golden Schrock, and I think we had an Auslese, and they had just picked the asparagus fresh from a local farms, and it was the white asparagus. And our waitress came, and my German was a little rusty, and I said, "What'd you say?" And the people at the table were my guests there, I was their guest. It was when I didn't live in Germany, and they said, "The white asparagus just got delivered. You got to try it." Oh, is it good? Anyways, that's percent volume. And now for the most important one. And that's molarity. Click, switches on. If I had a dial, like I said, and I can turn to 10, I've just turned it to 100. Whoom. All right, molarity. Hold on, I have to find my stylus because it's time for Dr. White to be subtle. What is molarity? I'll never ask for a definition of molarity in terms of words, but molarity, which is abbreviated by capital M, is moles of a solution, is a ratio giving the number of moles, you know what a mole is, of solute per liter of solution. And molarity is moles of solute per 1 liter of solution. Wow, I even typed this on the slide. Very important. No. And this is for quiz 4. Now, what this really means, in a lab, we don't usually measure we don't usually measure liters, we measure milliliters. So remember, 1 liter equals 1,000 milliliters. Therefore, molarity which is equal to moles per liter, since 1 liter equals 1,000 milliliters, this is the important thing. And molarity is moles per 1,000 milliliters. So what does this mean? Well, that's a good question. Since molarity and some instructors give it in milliliters and ask you to convert it or give it in liters or whatever. I'm always going to give you and ask you to use this. Molarity is moles of solute per 1,000 milliliters. Everybody see my whiteboard on your screen right now? Thank you, Brianna. And Jasmine too, and everybody else who got their thumb up. All right. Remember, molarity is abbreviated by capital M. And if you were asked 3 points, what does the following mean? And you see 2.75 capital M NaCl. As soon as you see capital M, that's molarity. Remember, molarity is moles of solute per 1,000 milliliters. So what does this mean? 2.75 moles of sodium chloride, NaCl, table salt, per 1,000 milliliters of solution. And that's what it means. Again, molarity, moles of solute. I'm getting excited about this because it is very important in chemistry. Moles of solute per 1,000 milliliters of solution. And when I worked for chemical companies, and part of my job was going to chemical plants for startups, new inventions like mine, and I helped supervise, we would make up different what's called stock solutions of chemicals based on molarity. Oh, this is fun. Let's do another one. And the question is, what does this mean? And I'll do this, then I'm going to have you have fun too. I share. Capital M. M means molarity. And what is molarity? It's moles of solute per 1,000 milliliters of solution. And after the chemical, after the capital M, what you see, a chemical formula, that's the solute. So this means, what it really means, 1.65 times 10 to the minus 3. Remember, molarity, moles of solute, and the solute is H2SO4. You'll learn later on that sulfuric acid per 1,000 milliliters. Oops, I forgot. I can't use cursive. I have to print. There you go. So molarity, moles of solute per 1,000 milliliters. Oh, you should have some fun. What does this mean? 7.566 capital M HCl. Your turn. And when you're done, give me a thumbs up. Again, what does that mean? Hint, molarity, moles of solute per 1,000 milliliters of solution. And when you're done, give me a thumbs up. I see one person done. A bunch of others are finishing up. All right, I think everybody's done, so it's my turn. Capital M means molarity, and that means moles solute per 1,000 milliliters. So what's the solute? HCl. That means 7.566 moles of HCl per 1,000 milliliters. That's supposed to be an M. And that's molarity, capital M. Oh no, we're out of time. All right, for those who didn't make it, I cut the test number 1 answers I went through out of the video. If you need help, come to my office hours Tuesday and Wednesdays from 6 to 7:15. If you can't make it then and need to see test number 1 answers, email me and I'll set up a time when we can meet together on Zoom. That way you don't, and I don't have to drive to COD. And with that, I'm done. Don't forget to practice problems a week from this Wednesday. And by tomorrow, I hope, or Wednesday morning at the latest, I'll have more information about quiz number 3, which will be a week from this Wednesday, that will cover the chapter on gases. Tomorrow, I will do, before the lab, I'll go through the gases problem set. After the lab, and if you're not around, you can watch the video, I'll go through a couple mole problems that students got wrong on test number 1. And with that, I'm done. Gang gesund. Goodbye.